Hello, my name is Mark Hamilton, and I manage the consulting services team here at RTI. Welcome to the RTI Connext DDS Introduction training video. RTI is the real-time infrastructure software company. We provide the messaging backbone for the world's most demanding real-time systems. RTI Connext enables applications running on the smallest devices and the largest enterprise servers to seamlessly share information and work together as one. Committed to open standards, open community source, and open architecture, RTI provides the leading implementation of the Object Management Group's Data Distribution Service Standard. Our customers are in aerospace and defense, process automation, financial services, energy, automotive, health sciences, and transportation. RTI is privately held and headquartered in Sunnyvale, California. RTI has worldwide presence with active development taking place at our corporate headquarters in Sunnyvale, California, as well as in Granada, Spain. RTI is the world's leading supplier of DDS-compliant messaging middleware. RTI has a market leadership with over 70% of the DDS market share, according to two independent analysts. RTI's technology is mature and proven, with over 500 design wins with a technology readiness level of 9. Here are examples of systems that leverage RTI's technology. Notice the common threads that run through these systems. First is that they are mission critical in the truest sense. System failure equates to loss of property and potential loss of life. Therefore, reliability is of the utmost importance. Second is that data is central to the operation and performance of these systems. They all rely on efficient movement of data from where it is produced to where it is consumed. If data doesn't get from source to destination on time, that is typically a failure mode resulting in consequences just described. This is what RTI's technology does. Gets the data where it needs to be, when it needs to be there. RTI Connext. Here we have an architectural view of the RTI Connext DDS product, which is our focus for this e-learning online training course. It's important to realize that the Connext family includes a total of 5 products, all built around the RTI data bus, which provides a high-performant, scalable software infrastructure for messaging and integration that enables real-time information exchange between applications and systems. Even though our focus will be on RTI Connext DDS during this training course, we'll also briefly introduce the Connext Tools, Connext Micro, Connext Messaging, and Connext Integrator products near the end of this module. Over the years, several integration architectures have been employed in order to develop distributed systems. Oftentimes, an application-centric approach is leveraged, which yields a system that is brittle, difficult to maintain, and requires integration logic to be embedded within each application. As new requirements are levied upon the system, enhancing the system's functionality is not only complex, but expensive due to the tightly coupled nature of the architecture. The centralized approach is also common, but yields poor performance when scalability is required. The broker design creates a single point of failure, a bottleneck, yielding slower failover capability and is ill-suited for high-performant autonomous systems. RTI's implementation of the OMG DDS standard leverages a completely decentralized architecture, delivering ultra-low latency, high throughput, with the ability to scale. Applications directly exchange data in a true peer-to-peer manner. There are no servers, no message brokers, or daemon processes acting as a bottleneck, choke point, or single point of failure. The Connext Foundation is designed on a software infrastructure that is fundamentally different from enterprise messaging solutions. The foundation is a data-centric messaging bus, or what we call RTI Data Bus. In simple terms, data-centric means that the infrastructure itself understands and has information, or metadata about the data that moves throughout the system. This relieves the application of having to track system state, which, along with the peer-to-peer architecture, leads to an order of magnitude advantage in scalability over other non-data-centric approaches. It also forms the most basic tenet of integration, since systems integrate with each other through an understanding of their respective data representations, which are present and therefore discoverable in the data-centric bus. We'll now turn our attention to the focus of this e-learning online training course, which is RTI Connext DDS. Before we get ahead of ourselves, let's address a fundamental question. What is DDS? In a nutshell, it's an OMG-compliant, anonymous publish-subscribe middleware standard that defines how applications within distributed systems can communicate information extremely efficiently by providing a standards-based API, discovery protocol, and extremely flexible quality of service policies. Also note that the Real-Time Publish-Subscribe, or RTPS, wire protocol provides seamless interoperability across implementations, platforms, and programming languages. DDS was designed from the start to support any programming language. RTI's implementation supports C, C++, Java, .NET, C#, and Ada APIs. RTI also supports many operating system platforms. For a complete list, please consult RTI's website at www.rti.com. RTI's implementation of the OMG DDS standard is not only standards compliant, but also supports advanced features such as allowing data to be published over all the available interfaces within a multi-home system, or only specific interfaces depending on the project's specific requirements. RTI's implementation of DDS also provides advanced quality of service support, as well as support for a vast array of platforms. For a full list of supported platforms, please consult our website or request a copy of our product array matrix by emailing us at elearning@rti.com. Let's cover some fundamental DDS terminology. You'll get much more detailed information within the following training chapters, but I'd like to establish a few terms at this point. Topics, which represent the data to be published or subscribed to, are registered with the Global Data Space, or DDS domain. Each domain has an index. For our simple example here, we'll refer to this domain as domain 0. Within domain 0, we'll show 3 domain participants. A domain participant is a software process that can contain either a publisher, subscriber, or both. The publisher can contain one or more data writers, and the subscriber can contain one or more data readers. Each data reader and data writer will be bound to a topic with a type, and will form a connection that will allow data of a defined type to flow between the two endpoints. The data flow will be consistent with agreed upon quality of service policies. Note that each pair, reader and writer, can have its own customized quality of service, creating an extremely powerful communication paradigm. The support of quality of service policies allows the application developer the ability to tailor exactly how the data is both published and subscribed to. For example, when publishing data, should the sample updates be published reliably or best effort? If commands are being published, strict reliability is most likely required. If periodic data is being updated at a rapid rep rate, best effort delivery may be appropriate. Does the subscribing application require all sample updates, or only one every 2 seconds? Incoming data within a subscribing application is cached. Should all delivered samples be cached before being read by the subscribing application, or only the last 5? How quickly should one of multiple data writers be taken offline after becoming unresponsive in a fault failover scenario? All of these questions must be addressed when designing a distributed system. DDS quality of service policies can be leveraged to address the required data delivery behavior. Content filtering is a good example of a quality of service policy that really leverages the power of data-centric middleware. Content filtered topics allow the subscribing application the ability to indicate that it would only like updates on a specific topic if and only if the content of the current sample falls within a user-defined limit. RTI Connext DDS will take advantage of being strongly typed or data-centric and will make the decision to writer-side filter if at all possible, thus preserving network bandwidth. If writer-side filtering isn't feasible, the middleware reverts back to reader-side filtering and only delivers the data samples that fall within the content filter limits. This removes the need for additional filtering logic to be designed into the subscribing application. For completeness' sake, this table is provided as a quick overview of all the quality of service policies supported by the OMG DDS standard. Covering all of these policies is beyond the scope of this introduction, but most, if not all, of these quality of service policies will be covered in subsequent training modules within this eLearning online training course. RTI Connext DDS is designed to be transport agnostic. By default, the product ships supporting UDP over IPv4 and shared memory. In most host-based operating systems, as well as select real-time operating systems, IPv6 is also supported as a transport. The key takeaway is that the core of RTI's technology isn't tied to IP or any other protocol. Custom transports can therefore be written and have indeed been written to support everything from wireless radios to PCI bus to many other types of transports. Lastly, a TCP transport is also supported if required. One of the benefits of leveraging data-centric middleware such as RTI Connext DDS is that as the application is enhanced from being message-centric to data-centric, the actual application code size is reduced, and sometimes drastically so. Why is this? Well, consider that RTI's middleware will remove the requirement for application logic to have to marshal the data, filter the data, cache and manage the state of data updates, and handle discovery, just to name a few. As a case study, let's take a look at the Joint Battle Command project that leverages RTI Connext DDS. The mission of the Joint Battle Command project was to track positions of friendly and hostile forces on the battlefield, with the design goal to be able to track 100,000 updates per second. The legacy capability required 500,000 lines of code, took 8 years to develop, required over 20 servers, and achieved roughly 20,000 tracked updates per second, with reliability and uptime challenges. After RTI Connext DDS technology was integrated into the architecture, only 50,000 lines of application code was required. It took 1 year to develop, required 1 laptop, and was able to achieve over 250,000 track updates per second, leveraging an architecture that introduced no single point of failure. Peer-to-peer performance. I'd like to briefly touch on the performance benchmark results we've measured while testing RTI Connext DDS. The details of our benchmark testing configuration can be found at the link on this slide. The latency results were achieved on Linux servers running CentOS 5.5 64-bit and communicating over our standard UDP IPv4 transport using reliable quality of service, which also provides ordered delivery of the test utilities data samples. These graphs show the average one-way latency in microseconds for publish-subscribe messaging. Latency was measured by having the consumer data reader echo back messages to the producer, the data writer. This allowed round-trip latency to be measured on the sending machine, avoiding time synchronization issues. The round-trip latency was then divided in half to get the one-way latency that is shown in the graphs. This data shows that latency remains consistently low as message size increases. Concerning throughput, this graph shows sustainable one-to-one, point-to-point, publish-subscribe throughput in terms of network bandwidth. It was measured between a single producing and consuming thread, each using a single gigabit Ethernet or InfiniBand port over a single DDS topic. Accounting for Ethernet, IP, and UDP overhead, the maximum bandwidth available for message data is slightly over 950 megabits on 1 gigabit Ethernet. As can be seen, Connext DDS is able to fully utilize all of the available bandwidth when sending messages larger than 128 bytes, meaning throughput is limited by the network and not by the CPU or RTI Connext DDS. Because RTI Connext DDS uses true peer-to-peer messaging with no centralized or per-node enterprise service bus, message broker, server, or daemon processes, it does not impose any inherent limit on aggregate messaging capacity. It is limited only by the network infrastructure. Chapter 9 of this online training course will cover in detail how to leverage the RTI Perf Test utility to characterize the performance of RTI Connext DDS running on your specific hardware and operating system platforms. At this point, I'd like to introduce you to all of the RTI add-on products that can be leveraged along with RTI Connext DDS. I'm going to briefly introduce you to RTI's current stable of ecosystem components, which include both tools and services. RTI Connext Tools offers a rich tool suite that helps you develop applications more efficiently and provides visibility into your running system. They enable you to monitor, analyze, and debug your complete system. Other services provide facilities for recording and replaying data in real time, routing and transforming, publish data samples, and much, much more. The RTI Shapes demo is a standalone graphical application that runs on either Windows or Linux and does not require any programming. This demo will help you become more familiar with DDS, quality of service policies, and the anonymous publish-subscribe communication paradigm, all in a single graphical-based demo application. The download includes a demo executable and a tutorial. After installation, I recommend that you read the RTI Shapes User's Manual to learn more. You can follow the free download link to obtain a copy and begin using the Shapes demo. Lastly, if you have access to 2 systems, I recommend running an instance of the demo on each of the systems and see how DDS Discovery allows the 2 demo applications to communicate over the IP network versus shared memory, which is the transport that's used when running 2 instances of the demo on the same system. The RTI Analyzer is a powerful system-level debugging tool that can find RTI Connext objects in a running system, organize them, and display their communication parameters. Match analysis helps you determine which objects, data readers or data writers or domain participants, have matching quality of service values and which do not. Analyzer provides an easy way to see the topology of your application and diagnose peer-to-peer communication problems. RTI Monitor provides extensive visibility into a running system, including health, performance, and topology. It displays the quality of service parameters for every RTI Connext entity in the system, as well as detailed statistics on connections, traffic, errors, and resource usage. Monitor helps you understand your system design with a graphical view into the entire distributed system. It also helps you verify your design by making sure the entities are communicating as expected, and tune performance by providing deep statistics on every aspect of the middleware's operation. Designed for developers, integrators, and operators, it eases application integration and testing, aids in diagnosing unusual behavior, reduces risk associated with connection problems and network usage, and provides ongoing insight into your system and components. The RTI Spreadsheet add-in for Microsoft Excel provides a turnkey bidirectional integration capability between RTI Connext DDS and Microsoft Excel. It allows cells formulas, and charts to include subscriptions to real-time data streams, such as market data, sensor data, with values updated automatically in a real-time fashion. Formula results can also be published in real time to other applications and spreadsheets. RTI Recording Service can record high-rate data arriving in real time with minimal impact on system behavior. It can reliably record large amounts of real-time data without having prior knowledge of the data types or the topics within the system. Recording Service is operating system and programming language agnostic, recording data from a heterogeneous network system running RTI Connext-enabled applications. RTI Recording Console provides a point-and-click graphical user interface for Recording Service, making it easy to use the Recording Service for testing algorithms and other processing logic against pre-recorded test data, conducting regression testing from golden data inputs, or recording live data from the field for post-mission analysis. RTI's replay capability allows recording data to be injected back into a DDS-enabled global data space. The replay feature allows you to change data rates and quality of service settings and provide fidelity to within 10 milliseconds of the recorded data rate. RTI's persistence service, among other capabilities, allows published data to be delivered to late joining subscribing applications even after the original publishing application is no longer available. The OMG DDS specification specifies 4 durability modes, which are volatile, transient local, transient, and persistent durability. RTI Connext DDS provides both volatile and transient local durability functionality, which stores published samples in local memory. The persistence service, running as a separate service or software process, enables both transient and persistent durability functionality, which stores published samples within the memory of the persistence service instance or in non-volatile storage respectively, and then publishes those samples when late joining subscribers come online. The RTI routing service enables information to be selectively bridged or forwarded from one DDS domain to another. The number of topics to be routed is fully configurable, as well as being able to apply custom data transformations to the data as it's forwarded from the originating DDS domain to the destination domain. It's important to note that routing service can also be configured with RTI's WAN transport, supporting both UDP or TCP, and providing a securely encrypted, authenticated communication channel between DDS domains located around the globe. RTI Real-Time Connect provides bidirectional integration between RTI Connext DDS and a relational database. It stores published data where a DDS topic becomes a table within the database. It also supports the ability for database table row updates to be published back into the DDS network. With a single instance, RTI has benchmarked storing over 100,000 messages per second using an in-memory database on a commodity 4-core server. RTI's limited bandwidth plugin bundle addresses the challenges of constrained network communication. The plugins are designed to overcome situations where the network is made inefficient by low or limited bandwidth intermittent connections. The plugins provide the ability to compress both the RTPS header as well as the data payload. In order to reduce discovery traffic, a static discovery plugin is also available. These plugins allow DDS-enabled applications the ability to operate over constrained networks while efficiently utilizing the available network bandwidth. Wireshark for RTI Connext DDS. Often, when problems arise, you simply need to be able to see what's happening on the wire. Wireshark is a network protocol analyzer that allows packets on the network to be captured, filtered, and then analyzed. Wireshark's graphical interface does a nice job of displaying the packets that are captured, dissects the packet contents according to any applied filtering, and lists or graphs the output for easy analysis. RTI has written an RTPS packet dissector and bundled it with Wireshark. By leveraging the RTPS packet dissector and Wireshark's filtering, one can capture and display only the packets that are of interest. As an example, One could choose to only analyze discovery-related traffic or metadata, or payload traffic. You could further filter the captured packets and only display discovery traffic flowing between two specific IP addresses. Wireshark for RTI Connext DDS is an extremely powerful debugging capability. The RTI Distributed Logger is a library that enables applications to publish their log messages to RTI Connext. The log message data can be visualized with RTI Admin Console, a separate graphical application that can run on the same host as your application or on a different host. The RTI Administration Console is a centralized tool for monitoring and administering your distributed system. In a single view, you can monitor the health information of your components, the CPU and memory usage of each participating host, and log messages from all applications using RTI Distributed Logger. The Administration Console also allows you to remotely administer other RTI components, such as routing service. You can pause and resume individual routes, retrieve currently running configurations, and even apply modifications to those configurations remotely. These features help reduce administrative overhead by cutting down time and effort required to understand your system. Here's a screenshot of the Admin Console being used to administer RTI infrastructure services that are visible on the network. You can check the status of each running service, review log messages, and update the configuration of each. Now that we've covered RTI Connext DDS and the ecosystem components, I'd like to introduce you to Connext Micro, Connext Messaging, and Connext Integrator. Connext Micro provides a small footprint DDS implementation for resource-constrained devices and applications that require certification to stringent safety standards such as DO 178C Level A. RTI is currently generating certification evidence for the U.S. government's highest flight safety standard. Connext Micro is wire compatible with RTI Connext DDS and provides a subset of the OMG DDS API. Also note that Connext Micro will include full source code distribution and be able to run on 16, 32, and 64-bit CPUs with or without an operating system. Connext Messaging includes Connext DDS and adds the new Request Reply API. Connext Messaging also includes both the DDS and JMS APIs, enhanced scalability, guaranteed delivery, application acknowledgement, type extensibility, and seamless integration with Connext Micro and Connext DDS. RTI Connext Integrator is a flexible integration infrastructure and is based on a proven foundation of technology and tools used in highly diverse systems, often with extreme real-time performance requirements. Connext Integrator's features include the ability to adapt legacy systems so that they can communicate with DDS-enabled systems, transform incompatible data models in order to help achieve interoperability, and bridge DDS-enabled systems across both LAN and WAN networks. Connext Integrator enables integration of disparate, geographically dispersed, and legacy systems. This requires the ability to adapt, transform, and provide the necessary choreography to bridge legacy and DDS-enabled systems. For additional information on Connext Integrator, please visit our website at www.rti.com or send us an email at eLearning@rti.com. My goal in this video training module was to provide an introduction to RTI Connext DDS and also provide information on our ecosystem or add-on software components. I also wanted to briefly introduce you to the Connext family of products known as Connext Micro, Messaging, and Integrator. For additional information on any of these products, please don't hesitate to email us at elearning@rti.com. My hope is that you will enjoy your online training experience and will find the RTI Connext DDS training course very helpful. Thank you for watching. Thank you for watching this portion of RTI's online training focused on RTI Connext DDS. We'd also like to remind you that there are additional resources located on our eLearning webpage at www.rti.com/elearning. We also invite you to visit our community portal, where you can post general or training-related questions and receive answers to those questions. Lastly, please feel free to send an email with your questions or comments to elearning@rti.com. Again, thank you for watching and have a great day.